Hello everyone, welcome to 12.1 day 2. In this lesson today we are going to continue with the arithmetic sequence, and specifically we're going to be writing equations using the explicit and recursive rule for an arithmetic sequence. So let's take a look at the first example, and here is a table that is consisted of terms, so the first 5 terms and the value of the term. So if you look at the list and you try to find a pattern, from 8 to 12, you're actually adding 4. And that's actually consistent for the next several terms. So we know that this is in fact an arithmetic sequence. So that's a yes. And so we're going to actually write both of the rules. Remember, there are 2 rules, and the first one is an explicit, and the second one is recursive. So we're going to start with the explicit rule. Explicit rule is, we already know the common difference. It's going to be 12, the second term, minus 8, and that is 4. And that's the number you are adding to get to the next term. And that's been shown in this table right here. So that's the common difference. So using the formula, notice that we have n starting with 1 from the table. So we're going to use the formula that says n starts with 1, f of 1. So if you recall that formula, it is f of n equals f of 1 plus common difference times n minus 1. So since we know the first term is 8, we're going to substitute that into the equation. And we also know that common difference is 4. We're going to substitute that, and n minus 1 just comes with the formula. We're going to keep that there, and we're going to simplify by distributing the 4 and then combine like terms. So it will be 8 minus 4, which is 4, plus 4n. So we know the formula for this, the explicit rule, is 4 plus 4n. And it also says that the domain, so since this list is actually finite, which means it stops at the 5th term, we can specify the domain for this list of sequence. So we can say that n actually goes from 1 to 5, and that's the domain. So specifying the domain because it only goes up to the 5th term. If you see those 3 dots at the end, that means that this is an infinite list and it keeps going. But for right now, this is a finite sequence. A recursive rule, the second one, is pretty simple. We start with stating. Basically, we're saying the first term is equal to 8. We're making an announcement. And then from there on, we just say, hey, to get the nth term, you take the previous term. It's always going to be f of n minus 1. And we add what? The common difference. Remember, we're adding the common difference. So in this case, is 4. And again, we need to specify the domain for this because it is a finite list. So since the first term is already given, we're going to just specify that for the rest of the term, it goes from 2 to 5. And that is how you specify the domain for the 2 rules. So explicit and recursive are the 2 separate ways. Hopefully you guys are getting the hang of it. We're going to do one more together, and then you get to try one on your own. So the next example is another table. Notice this time n starts at 0. And so I'm going to show you that even if it starts with 0, if you like the formula that starts with 1, you can just use the one with the first term, term 1. So I will show you what I mean right now. First thing is, let's try to find a pattern. So from -7 to -2, we add 5. And from -2 to 3, we also add 5. From 3 to 8, it appears that every term to get to the next term, we're adding 5. So that is very consistent. So we can conclude that, yes, this is an arithmetic sequence. And D is actually already given here, but we're going to actually show the work for it. So let's write down the explicit rule and the recursive rule. And so for the explicit rule, to find the common difference, it's you can take any of them. So I like working with positive numbers, right? I think you do too. So 8 minus 3 will give me 5. That's how you show the work for the common difference. Now for f of n, this is what I mean. If you want to choose the formula that goes f of n, so let me see if I can go back to day 1 here. The formula right here. So this is the first term. Okay, there's one also for the 0 term. So technically, we can use this. Okay, I will show you that it is actually going to give you the same answer. So we're going to start with the f of n with the f of 0. So f of 0 plus d times n. So we're going to scroll back to our problem, and here we are. So we're going to start with the f of 0 plus d times n. So if we start with this one, that will be -7 plus common difference is 5n. And so f of n is equal to 5n. We're going to just leave it -7 plus 5n. And then if you use the second method, the second formula, I mean not method, f of n equals f of 1 plus common difference times n minus 1. It will be the same. So if we use n of 1, then we're going to start with -2, right? So -2 plus common difference is 5 times n minus 1. And just distributing the 5 will give me plus 5n minus 5. Combining like terms will give me -7 plus 5n. And what did I tell you about the answer? It would be the same. So either formula is fine as long as you find the matching one to work with. So it's either way is fine. So for the recursive, again, you have two choices. You can start with f of 0, but let's start with f of 0 because that's the one that is given in the table. So we're going to start the equation with f of 0 is equal to -7. That's the given. That's like making an announcement. This is how the list starts. F of n is going to be the previous term, f of n minus 1. And what are we doing every single time? We're adding 5, right? So we just add 5. So it's saying take the previous term, add 5, you'll get the next term. And then this is going to be for n goes from 1 to 5. So the 0th term is given. And then for the first through 5th term, you just take previous term at 5, and that is how you will describe using the recursive rule. So we've done two problems together. Now you guys are going to go try one on your own. So go ahead and try this problem. Pause the video first, try it, and then check your answer. So hopefully you've had a chance to try the problem. To figure out the common difference or the pattern, 11 minus 6 will give me 5. 5 minus 6 will give me -1, and it appears again that everything is consistent. So yes, this is an arithmetic sequence, and the common difference is apparently -6. So we're going to describe it using both explicit and recursive rule. And once again, the common difference is 5 minus 11, which is -6. And then f of n, we're starting with the first term, so we're going to use the one that says f of n equals f of 1 minus d times n minus 1. So once again, it's going to be 11 minus 6 times n minus 1. Doing the math, distributing it, -6n plus 6. 11 plus 6 gives me 17. So I have f of n equals 17 minus 6n is my final formula for the explicit rule. And this one goes from n equals 1 to 6, right? So we're going to describe it. N goes from 1 to 6. That's the domain, okay? And then for the recursive rule, this is the easy one. So we're going to just say f of 1 is equal to 11. That's the first term. To get the next term, f of n, it's going to be previous term minus 6, right? Because we are subtracting 6 in every problem, every number to get to the next term. So that goes from term 2 to term 6. So the domain for this one is going to be n. N goes from 2 to 6. And that is the difference between the two methods for describing the rule. So hopefully you get how to do that now. You will get to practice more of that when we do the book set later. Then let's move on to example 2. Example 2 is just taking a look at how to graph these arithmetic sequence. So we're going to start with f of n, the first one here, which is a list. So I think that it would be beneficial if we start a table to actually collect the list of terms. So we start with n, and then here's f of n. And we're going to go from n equals 1 to 7. So here's n, 1, 2, 3, 4, 5, 6, and 7. And we're going to just do the math for each one. I'm going to replace n with the number here. So when n equals 1, it is 8 minus 1/2 times 1 minus 1, which is 0, that's gone. It will give me 8. So at 1, I am going to have an 8 right here. So I have a first dot, which is right there. And then when n equals 2, I'm going to let that be 2. And so it is going to be 8 minus 1/2 times 1, which is just 1/2, or 7.5. 7.5, 7.5. So n equals 7.5. So at 2, it is 7.5, and it looks like it's right there. When n equals 3, then we're going to let that be 3. So that will be 8 minus 3 minus 1 is 2. So half of 2 is 1. So 8 minus 1 is 7. So at 3, it's going to be 7. And at 4, it's going to be 8 minus half of 4 minus 1. That's going to be 1/2 times 3, or 8 minus 1.5, which is 6.5. So apparently this list is going down. If you know the pattern, that look at the common difference is negative 1/2. So you can just continue the pattern and say, hey, I'm subtracting half a unit. So it's going to go 6, and then 5.5, and then 5, right? So you can just keep going with the pattern, and you should end up with something like this. And it should be a straight line forming. You don't need to connect the dots because it's a sequence. So we're just going to leave it like that for the problem. This is how you graph it. Let's try one more. So this one is similar to the one that we just did. And this one says for anything greater than 2. Notice this is not a finite list. It's going to keep going. So we're going to say n and then f of n. So we know the first term is 4 already. It's given. And then notice this formula. It is given. You need to start to recognize the formula, the form that is in. Like this one, you can tell that this is recursive rule. Whereas the previous one, it's actually a formula. So that right here is actually explicit form. So here we have recursive form, and we can easily identify the next term. So it looks like the common difference is going to be negative 0.25. So you're subtracting a 0.25 unit from the previous term. So the second term is going to be the previous term minus 0.25, which should be 3.75. And then you're going to minus 0.25 again, would be 0, which is 3.5. And then the fourth term will be subtracting 0.25 again, which is 3.25, and so on and so forth. So I'm going to just stop it right here to say that it keeps going. But it is consistent. So we're going to start with the term 1 and then 4, the dot right there. And then at 2, it's going to be 3.75, which is like right there. And then at 3, it's going to be 3.5 right here. And then at 4, it's going to be 3.25. I think I drew this one off. So 3.5 at 3 right here. And then at 4, it's going to be 3.25, which is right here. So that still look like it's linear. It's going in a line form. Okay, so that's the end of that problem, just to graph the sequence. And let's go ahead and have you try the next one. So here's an opportunity. Go ahead and pause the video and try it on your own before you check the answer. Okay, again, hopefully you've had a chance to try it, and notice that this is also going to be whenever you see f of n minus 1, you know this is a recursive rule, which means you need to start with the formula with the first term that is given. So it's given that 0. At the 0 term is going to be negative 3. And it looks like a common difference is -1. That means you're going to be subtracting 1 to get to the next number. So the first term is going to be -4. Subtract 1 again, you're going to get -5, and then -6, -7, so on and so forth. Okay, so we're subtracting 1 to get to the next term. And so let's go ahead and graph that. At 0, it is -3. At 1, it is -4. At 2 is -5. 3, -6. 4, -7, so on, so forth. Okay, and it keeps going. So that is how you graph this one. Hopefully you got it right. Then we have come to almost the end of this day. So let's go ahead and take a look at the discussion question. How is the domain of a linear function restricted if the function defines an arithmetic sequence? So the domain, because we're talking about n, the number of term, n is the number of term, they have to be whole numbers. Like, for example, it has to go from like 1, 2, 3, 4. So that would be the restriction. You can't say, hey, 1.5 term. There is no such thing. It's either term 1 or term 2. You cannot say, oh, term 1.5. There is no such thing. So that would be the restriction. Okay, and that's the end of today's lesson. Yay. So go ahead and get started with the homework, and see you next time.